Here we go, and we are all started. All right. We are ready whenever you are.
Okay. Why don't you start with just telling me the status of your project and where you think you need to go in broad strokes between now and the contest in New Mexico?
Can you get it again, please?
He just wants to know kind of where we're at.
Okay. So right now, we just finished our second test flight. We had a fully nominal flight, and we don't have to do much building rocket wise. The only thing we have to get finalized is the nose cone and the attachment with the payload. And the other thing is we need to paint the rocket and get that smooth force spacing.
Okay. And to be honest, painting and smoothing out is just it'd be nice if you can do it, but if you gotta fly it naked, you gotta fly it naked.
Yeah.
Okay. You said you were still working on the nose cone. Has the nose cone been created yet? Or is it still a virtual nose cone? Or a nose cone in potential, shall we say?
So this is our current nose cone. We can bring it closer, Erica, if you want to bring it closer.
I can't bring the computer.
Okay, here we go. So this is our current nose cone. It's made out of FDM PETG, and we sprayed it with filler primer, and we put a final coat of paint on it. The kind of off color that you see is that we put some epoxy around it to try to fill in the gaps and before our past launch. But this nose cone did fly and it performed nominally. There were no issues. And also we have a centering ring inside the nose cone to help with the structural rigidity so it can deal with the flight forces.
And we
Okay.
have flown, like the past 2 years, we've gone to this spaceport competition and flown that with this same material of 3D printed nose cone. We know that it's not going to melt or have any of that type of issue. I know that was a concern with safety reviewers in the past, but it has proven effective in the New Mexico heat.
What category are you guys competing in again?
I'm sorry, could you repeat that?
What category are you competing in?
The 10K COTS.
Okay. Just a PLA nose cone at the speed of friction with a 30K rocket could be an issue, but at 10K, you're going to be just fine with what you've got. I agree 100%.
Yeah.
Obviously, your payload is not going to fit in that nose cone. So where is your payload going?
And our nose cone isn't actually made out of PLA, it's PETG. So it has a higher,
Gotcha. Thank you. Yep.
that higher heat tolerance.
This is the payload itself. It's gonna go in the payload tube.
Which,
Yeah,
correct.
this is
We have to cut a new payload tube. This
it's
one
a
is
little longer, but
too
it's
short.
gonna go here and then that's kind of on top.
Okay. And so obviously your nose cone is the thing farthest to the right. And then as I'm doing a top-down stack of your rocket, the payload bay, the one you just had in your hand, the larger of those two upright modules, is the airframe that your payload is going in. That's going to go just below the nose cone.
Yeah.
And then there's another airframe that's directly in front of you. That is going to go below the payload bay?
Yes, this is our main parachute bay, so it'll sit in like that. I'm not gonna try and adjust it properly now.
Oh, yeah, that's fine.
But this is our main parachute bay. We're doing a laundry line style deployment. So we'll have shock cord running through this, and this is where our main parachute will be connected to our altimeter. This is our altimeter bay coupler section. This is where all of our recovery electronics will be.
And that is between your booster and your parachute bay.
Yes, and the
Okay.
down in the fin can.
Okay. And what joints are going to separate during the flight of your rocket?
All of these sections. This will be attached here.
Yeah, so the main joints that are going to separate is that
These 3 pieces.
yes, so there will be so So inside here is what we have, what we call a charge plate, which is basically a small coupler section with charge wells on it. And this is where the drogue is housed, so through 4 shear pins, these, this section will separate here for the drogue. And then at 800 feet, this section, which will be connected here, will separate, sorry, this section here will, this side is riveted in to the, this,
Say backwards, it's much.
it's okay. This side is riveted into the, top of the, avionics bay, and this side has shear pins going up to the payload section.
So your avionics bay will detach from your booster along with your parachute bay and the forward half of your rocket
Correct.
Yes.
And that's,
at apogee.
yes. And
Okay,
800 feet, this is the charge plate that goes on the top of our avionics bay that'll deploy our main parachute at 800 feet.
gotcha. Okay,
It's down in there, the charge plate. I mean, we can pull the charge plate out, from here. It's just, it might be compacted in due to the launch forces, so we don't wanna have to ram anything out for you, but it's basically this same design, but it's, but without the, U-bolt, and it's on top of a, 4-inch coupler section.
so the charge well that is going to deploy at apogee is not actually housed on the rear centering ring of your avionics bay. It's actually, there's going to be a wire running from your avionics bay down to another bulkhead to connect the two.
Yes,
Yes.
there's wires running down to basically the base of the thing pan where the motor retention is. Down to, sorry, where our motor mount is. Above that goes that 4-inch coupler section with the charge plate. With the drogue and the first shock cord sitting there to deploy out the front half of the rocket.
So just out of curiosity, what made you design it that way rather than simply putting your charge wells facing downward out of your avionics bay?
So the reasoning for that is, in the past, I think it was 2 years ago, we had issues with when they were facing down into the base of the rocket. They actually compacted parachutes further in to the fin pan area, and that caused a non-nominal flight. So in order to, instead of pushing the parachutes back in, we wanted to push the parachutes out. So we put the coupler section in the base above the motor, so we could have a better assurance that it was separated.
And the drogue would deploy.
Okay, and in the bay between your charge plate and the bottom end of your electronics bay, your avionics bay, what else is in that cavity other than the wires that are running down to your charge plate?
Our bottom shock cord, which is a 25-foot nylon, tubular nylon shock cord, and our drogue parachute in a small parachute protector.
Any quick links or couplers or anything metal?
So there's gonna be a quick link attaching that shock cord down to the bottom of the avionics bay. And the attachment down to the forged eye bolt on the motor. So the
Okay.
shock cord only run, there's a hole in that charge plate. There's a hole in the middle of that bulkhead where on this top one, there's a U-bolt for the shock cord to run through.
What concerns me a little bit about your design approach, and I'm not saying that it's unsafe or unsound or anything like that, but just as an experienced rocketeer, one of the things that concerns me a little bit is that because typically the wires that run from your avionics bay down to your charge wells are fairly thin wire.
Mhm.
During flight forces, when you have heavy things in that bay like quick links and things like that, you just want to make really sure you're not somehow, as things settle or shift or vibrate or move around, that somehow you're going to separate those wires and now all of a sudden you aren't going to have any separation charges fire.
Got it.
We're not so much worried about that because there is only that one quick link attaching the shock cord, which has a sewn looped end on it. It just attaches there at the end of at the end of the altimeter bay, and then all the other metal is below the charge.
Okay, fair enough.
So, one thing that we use to, so the wires are separated, is that we have the, terminal blocks right here. And these are, the JST connections, and this is this is one end that, this is facing down into the altimeter bay. And the other
Sure.
are coming up to meet here, so they're separated enough, so they, and we're sure when we're putting this all together that we don't shift the rocket too much so it doesn't torque the wires off.
But those plugs are just pressure fit plugs, correct?
I, are they?
Yeah, the JSTs are just a pressure fit.
Okay. So if something settles on top of a lower loop of that wire or something within that bay, it has the opportunity to pull that plug loose.
Which is why we leave plenty of space. It's not exactly a taut cord. I wish we had examples of our JSP connectors down to our charge plate, but we do leave an excess there, and they stick out in our group.
Here's an example of the excess.
So it sticks out fairly far beyond it, and then all of that extra cord goes above. It goes above any of the shock cords that are going in there as well.
And like,
Okay.
So we have this on slack here as well.
this is it being pulled right now with some moderate force, and it's not,
It does take the force of the ejection charge really to pull them apart.
yes.
Sure. Just because we don't know who's going to do your flight safety review. And different rocketeers have different approaches to things like that. Your approach to your apogee deployment is non-conventional enough that you can expect to see some additional scrutiny as you're going through your flight safety review. Are any of you high power certified?
I'm level 1 and
I'm
she is
level one. We have 2 level 1s and our flyer record is a level 2.
Okay. Your flyer of record is a level 2?
Yes, because we only plan on flying on an L1115. So
Gotcha. I'm sorry, I had forgotten that. I read that from an earlier review and I had forgotten that you guys were only flying with an L motor.
yes,
Now, was it because the L motor worked best for you, or you couldn't find a level 3 flyer of record, so you limited your flight?
So we couldn't, due to just the circumstances, we couldn't find a level 3 at the time, and our flyer of record couldn't obtain the level 3 requirement in time for spaceport.
so we designed this rocket specifically to work within a level 2. Obviously, if our flyer record is also our team advisor and mentor. So it's keeping that knowledge within our known bounds so that we're not trying anything new by the time we get to spaceport.
Okay, great. And your rocket has simmed to approximately 10,000 feet at least?
Yeah, so in the simulations vary from around 9,975 to 10,025 right now.
Sure. But you guys do understand those simulations are of nominal use in trying to predict reality, let's say.
Yes, we are aware, due to just our past experience in spaceport, that we're gonna sit, we've typically been right around 5 to 10% lower than our predicted apogee. We have.
Yeah, that's a good safe number to work with. I agree with that 100%. What sim software are you guys using?
So we're using OpenRocket, and so one thing that we're going to take into account during during spaceport is we're going to weigh our motor grains and see if they're off the predicted of what it says on thrust curve, and if they're, if the grains are less, there might be extra or less boost from the motor.
Okay. Let's see. So your ConOps is the rocket obviously launches whole. It separates at apogee at the first breakpoint just above the booster, taking the electronics bay in the top half of the rocket with it.
Yes,
And then it's going to fall under drogue.
Yes.
And then at what altitude is the main going to deploy?
It is 800 feet with a backup at 700 feet.
Okay. Have you confirmed that 800 feet is okay within the DTAG?
Yeah, we had the questions in our first safety review, and our first progress report about whether that was sufficient, as Anita, the lady who was our safety reviewer at that point, did ask, since they typically see deployment at 1,000 feet. But since we've seen it successful the past 2 years at spaceport and within our test launches with this particular rocket, they feel fine and safe with us deploying at 800 feet as a mission.
And,
Okay, fair enough.
and if the safety reviewers deem it so, at spaceport, we can always change, our altimeter configuration.
Okay, that's fair. Yeah, just because, and I don't have the rule book memorized because it's too damn long. Some people may, because I think the book says 1,000 feet, depending upon who your reviewer is, they may be a very by the book kind of person and they're going to demand you shift it to 1,000. But if you can it sounds like you can make legitimate reasons for why you want to be at 800, and the difference is pretty nominal. So I would be fine with it if I were doing your safety review, but I won't be. So you'll have to wait and see what that person says. Okay, so then let's talk a little bit about your payload. Is anything going to deploy from your payload, or is it going to be captured the entire time?
It's gonna stay the entire time, nothing's deploying.
Okay, what's it doing?
So, our goal is to use thermoelectric coolers to test cooling a compartment, because in the past we've had some issues with overheating. So in the very top part, we are putting an egg restraint system to just see if an egg can survive these forces. Then right here in the second section, we're having a thermoelectric cooler, then a heat sink, then a fan with some vent holes so we can expel the heat out. And then also another thermoelectric cooler in this second component, this other one. And then in the middle, we're gonna have 2 run cams. So we can have one facing out on the horizon and then an external fold mirror so that we can see like a bird's eye view of the launch. And then below that, we're gonna just have some batteries and an Arduino. So we can have temperature sensors both in the cooled section where the cameras go and in both the thermoelectric cooler sections to see how hot it gets there. And then our batteries down here for the coolers.
Okay. Are you going to be transmitting any of your data, or are you just capturing it on your Arduino and you'll pick it up when you recover the rocket?
Yeah, we're capturing it on the Arduino and then we'll read it later.
Yes.
Okay.
The egg survived our test launch under a K1100. So
Give a bump with it.
so we're pretty hopeful it'll survive an L, but I'm not saying any promises right now.
We might find
You
scrambled.
still might want to put it in a Ziploc bag or something when you go to launch it on the contest day, just to minimize the mess in case of an unfortunate incident.
Yeah, we will be sealing it so it doesn't leak scrambled eggs all over our rocket.
There you go. And if it's that hot a day, the thing may be soft boiled by the time you launch it anyway. So, okay. So I know your team has been out to the launch before. Have any of you been to the field previously?
I have been to the field.
About of the team that we're bringing, we're a fairly small team, as you can see. We're only bringing, I think, 8 or 9.
8.
We're bringing 8 team members with us, and 4 of those are returning from last year.
Great. Then for those of you that aren't going to believe the 4 of them that tell you about how bad it is out there during the day, you should believe them. It really is that obnoxious out there. Okay. Your flight avionics, do you have your sled handy?
Yes.
Flight control avionics.
I'll take it up to you.
What are your altimeters you're using?
We're using, for our main charges, we're using an RC3. And that's going to deploy at apogee and deploy at 800 feet as well.
Sure.
And then for our backup, we're using a perfect flight stratologger that is a 1-second delay from apogee and deploys the main at 700.
Okay.
And
I see a antenna there. Is that your GPS unit?
Yes, we have a featherweight GPS tracker. And we also have a Big Red B 70 centimeter finger to help whenever we get closer.
Okay, the Big Red B, does that require a ham license?
Yes, it does.
And Team Mentor does maintain a ham license, and we're working to make sure we're registered with all of our frequencies and everything.
Fantastic. I just need to make sure that the bases were covered. Okay,
Our altimeters are powered by two 9-volt batteries on the backside, which we have 3D printed mounts for, which are also zip tied in. And then our trackers are powered by two 4-packs of nickel metal hydride batteries, which we will also be zip tying in.
And these are all turned on with, I think it's shutter, rotary switches. And these, are turned on via, going by using a flathead screwdriver on, the launch pad to turn them on. And so these holes are lined up so we can, they're lined up with the key switches, so there's no finagling around to try to find them. They're lined up, and we've done it for 2 launches, and they have lined up great, and we turn it on within 15 seconds for each key switch. Or
you do know that Murphy hears you when you say things like that, right? And he's going to screw with you when you get out there in the desert.
Oh, yeah, okay, yeah,
Last year, it did happen last year where we were finagling with it longer than we had liked. And we have done some more mitigation on making sure that the holes line up properly, but obviously we're prepared if they don't we have a work checklist and everything ready if things go extremely wrong. But we are, for the most part, sure that we can at least get something in there to turn them on the pad.
Sure. Did you guys consider, since you have that switch band in the center of your electronics bay with a piece of airframe there, did you consider attaching your switches externally?
yes, we did, but the only problem with that was that what we had in the past, was there were a lot of wires coming, going down into the, avionics section. So when we were putting, everything in, there was often an issue with the wires getting tangled. So we embedded them in the sled itself to kind of reduce the amount of wires being around inside that bay.
Okay, that's fair. And turn, if you would, stand your booster up vertically, if you would, and just hold it for a second. Okay, so your electronics base is just going to be up at the top of that booster section, correct?
Yes.
So you're not talking having to climb a 12-foot ladder to get up to your switch band or anything like that. You might even be able to just reach it standing from the ground.
Our team, we're gonna
So,
ladder just in case, because we found that at spaceport, they usually sit the ends of the rockets up a little bit higher. But our team lead is plenty tall to, if it's not too high, just do it from standing on the ground, and if it is, we have a small step ladder that he'll be able to step up on.
sure. Okay, let's talk about your booster a little bit. How are your fins attached?
So our fins are attached with, trying to say, they're through the wall cuts in, into the,
They're pre-cut fin slots. in
fin
our
slots,
fin
that
list.
was the word, I couldn't get the word. They're fin slots, and so with these fins, they have, a slot, in the middle of the fin tab. Notch slot, and we slot those into, and then there's a centering ring in the middle where that notch slots into. So before we put a fin on, what we did was we laid epoxy down into that fin slot, then we put the fin on after we put that epoxy in. And then after that, we laid the rocket like this for each fin, and we had a level to try to after we put the epoxy on either side, we had a level to make sure they were perfectly straight for each fin. And after that, we were like, okay, we need to do the fin fillets. And the fin fillets, what we did is that we used the West Systems epoxy, and we had the epoxy filler as well. With the glass microspheres, and we had fiberglass cloth. So what we did, so the process was, first, we laid down and also we had carbon fiber shavings that we mixed in with the epoxy. So what we did was, we first laid the initial epoxy mix down in the fillet. Then we took the fiberglass sheet, of course with gloves and a mask, we pushed the fiberglass cloth down into the fillet so it soaks inside the epoxy. And then we put another band of epoxy on top of the fillet. And then, and Erica's gonna show you a quick picture of it.
From our technical document as well, but that's that fiberglass cloth laying over the top of the first epoxy layer before we put that second layer down. No, it's not the greatest picture.
And those are just bands of cloth. They're not tip to tip or anything like that?
No, they're not. They're just down the center portion. We did them as close to the ends as possible. But we did not wrap them around the bottom just because it would have added bulk and space, and we were worried about the end of our fin can being cluttered with epoxy.
And additionally, Erica, if you want to talk about how you did the sanding and filler for the fillets.
I mean, Mike can talk about that too, but after we had that second epoxy layer over the fiberglass cloth, Mike and I, and our flyer record did use some fiberglass fillers like Bondo filler to kind of smooth out because it was quite rough and we didn't want to have such a rough surface going up. So just to fill over the top of it and to fill in the ends to secure the top and the bottom of the fin as well, we used filler, and then Mike did a lot of work sanding those down and getting them ready for flight.
Okay. Motor retention. How are you keeping your motor in place?
So we're using a slimline motor retainer for it, and so we didn't use the outer motor retainer this year, and this was just due to the way our fin can was constructed. And right now, the motor is currently still in from our last launch, and there's a little dirt in there because it fell on that side. So when it hit the ground, the motor didn't come out. So and we tightened it down with the tool as well with usually it's a flathead screwdriver we help tighten it down with.
And you just haven't bothered taking the motor out, the motor case out yet, or you can't take the motor case out at this point?
We haven't had, we did this last test launch right in the middle of our exams for our university were Friday, Saturday, Monday, Tuesday. We did this launch on Sunday.
Yeah.
So we've been a little bit busy, and it was in our flyer records car, so we had to get it back from him.
Yes, so I mean, we can get it out in 10 minutes at most.
That's even an overestimate.
Yeah, we can still get it out, it's just the fact that, you know, we
Haven't
kind
had
of,
the chance to.
yeah, we got it back earlier this morning to prepare for this, so.
Okay, and I'm sorry, because the camera is a little bit away from the booster, I can't really tell for sure. The slimline retainer comes in a couple of different flavors. Is this something that's retaining the rocket from the rear, or is it retaining it from the front of the motor?
Can you say it again?
I have seen slimline retainers that are designed to hold the motor around the base of the motor itself. Then there are other slimline motor retainers that actually slide up into the motor tube and retain the motor from the top. Which way is this one?
So it's the one at the base, the whole.
Okay.
And.
Yeah, if you can bring that a little bit closer, I would appreciate it.
And this is a different size motor, obviously they're like different diameter motor, so there is an adapter in there.
I can you flash it real quick? Here.
Put some more light on it.
Use the,
Okay.
there you go. This little,
A little dirty, but
So one of my concerns is about force transfer. How the force of the motor is being transmitted from the motor itself through to the airframe of the rocket, which carries the base of the bulk of the load as the rocket flies. As I understand it right now, your retainer is not connected to both your motor tube and the airframe. It's only connected to the motor tube, correct?
I'm fairly sure, yeah, it just screws in.
Okay. So then, other than the fact that your fins are through the wall and you epoxied them to the motor tube, how are you transferring the force of the motor to the airframe of the rocket?
So,
Or is that how you're doing it?
so the centering rings take a lot, of the force on that. And because they are, interlocked with the motor mount itself, that's what helps transfer the forces. And as well, we have 4 centering rings instead of just 3. So we have one near the base. We have one that interlocks with the fins. And then
Mid-fin, yep.
we have one at the top of the fins, and then we have one up about right here. But sorry, it's about like right here. So we have
At the
4
top.
center rings, top of the motor mount, yes.
And all 4 of those centering rings are epoxied to the motor tube and to the inside of the airframe.
yes.
Yes, and
Okay.
so,
With with the microspheres and carbon fiber shavings in that West Systems epoxy, which is an hour-long cure epoxy. So it's not going anywhere.
Okay, fair enough. And you're only talking an L motor anyway, so you're not talking about a super high thrust N10,000 or something like that. Okay,
It's an
very good. Trying to think of other things we have not discussed yet.
our main we have our drone parachute here, but where do we know for the chakras?
what you said?
The other chakras.
No,
So with our recovery and our shot cords, since we are doing a laundry line deployment, we will have the main parachute and the main top end shot cord will attach here to the top of the payload bay, to the bottom of the payload bay, and then with the 2 larger cords, the one coming from the bottom of the fin can and the one attaching the top of the altimeter bay to the bottom of the payload bay, are going to be 25-foot shot cords, tubular nylon, and then our attachment from the payload bay up to our main parachute is a 12-foot tubular nylon cord, so that it comes down in that nice long laundry style, so we can find it all attached to each other. And at our last test launch, when we did it, it came down beautifully. It was this nice long line just laid out across the ground. It takes a lot of the jarring out of the impact onto the ground, because
Sure. Especially once your motor hits, then all of your heaviest item is now sitting on the ground as the rest of your rocket settles down. So that works great. Obviously, since you've test flown the rocket, you've done some ground testing, and are you comfortable with your deployment charges after your test flight? Do you need to modify them in any way?
No, we've done ground testing and our test flights with our deployment charges being 2.5 and 3 grams, and they are for our main and our backups, and they've worked beautifully. And honestly, it throws it pretty far on a ground test. So
Which joints are you using shear pins on?
so the joint we're using shear pins is the top of the tin can. As you can see, we still have a little tape where we put the tape on top of the shear pins from the last launch. And here.
and then here again in the main parachute bay where it attaches to the payload bay.
And what are you using for shear pins?
So they are, I forgot the exact brand.
They're number 4 nylon shear pins.
That's exactly what you were supposed to say. They're 440 nylon shear pins. Yep. Okay. And how many of them are you using?
So
4 on each.
yes.
Okay, great.
So 8 total wouldn't be, but 4 on each deployment, each separatable section.
Mm-hmm. All right, I don't have any more questions, I think. I'm not, unless I come across something that leaps to mind as we're talking any further. Do you guys have any questions for me?
Um, not at the moment, no.
Okay, that's fair.
Anything? I think we're just all kind of excited for those of us that are returning to go back, and we've obviously like doubled our team and almost doubled our team in size from last year, so we're just really excited to get more people involved and keep everyone's hands on every part of the rocket like we have in the past, and we're just getting ready to go.
That's right, and it sounds like you're in great shape. Having it on your test flights, that is going to be a big thing. Make sure you're mentioning that you have level 1 certified people on your team and that you have had successful test flights of this particular airframe as you're going through your flight safety review, because that's going to tell that person a lot right off the bat without telling them anything more. That's some safe assumptions that they can work from. Guys, I think you're in good shape. I am going to go through and put your score in for the system. It's not really a score. It's just saying, I've seen your video review and you guys are, as far as I'm concerned, ready to come to New Mexico. So obviously you've got a little work left to do on your payload and getting that ready to go, but at least from a mechanical standpoint, and my primary focus in flight safety is the rocket rather than the payload, because as long as your rocket flies safely, I'm happy whether your payload works or not, to be completely honest with you. So you've got some work left to do getting your payload ready, but you've got a good amount of time to do that. Your rocket is in great shape. I look forward to seeing you guys in New Mexico.
Awesome.
Sounds great.
You too.
All right, and you know that you will send a recording of this that you're going to have to release. You'll have to change the settings on it so that the person who receives it can use it, because sometimes Zoom password protects the recordings they make. You'll send that to general info at HeroX, and or the general information thing for the recording, and that should have you guys good to go.
Right. Thank you so much.
Thank you so much for
I'm
coming.
gonna go ahead and stop this recording so it actually